The shortcut button to open the laser configuration and control window, this one here, will be enabled if a laser is connected to the system and has been successfully detected and initialized by LIBSoft. Selecting the shortcut button will display the window on top of the main LIBSoft screen. The parameters displayed in this window are the same for all lasers except the Lightron Bernoulli laser. The differences in the configuration window for this laser are described at the end of this video. During an acquisition, the operation of the laser is controlled automatically by the LIBSoft application. This window allows the user to configure parameters to set the laser energy and repetition rate used, and it also provides controls to allow the user to fire the laser manually if required. At the top of the laser configuration window there is a continuous display of the laser temperature and the parameters that control how the laser operates. The repetition rate parameter allows several discrete rates up to and including the flash lamp frequency of the laser to be set. This is the repetition rate at which the laser will fire a burst or continuously if the manual laser controls are used, and also while acquiring spectra. The repetition rate will, however, be automatically set to the maximum rate for the laser when firing conditioning shots, in order to minimise the time it takes to fire these shots. The laser repetition rate doesn't affect the acquired spectra, however, depending on the performance of the computer and the type of spectrometer used, acquisition timeouts could occur at higher laser repetition rates. If occasional acquisition timeouts are observed, the first course of action is to reduce the laser repetition rate. The number of burst shots parameter, this one here, sets the number of laser shots that will be fired when a burst is initiated using the manual controls. The number of shots fired during an acquisition is determined by the acquisition configuration parameters. The value of flash lamp Q switch delay is used to set the laser energy. Generally, the lower the value, the higher the energy. The range of values applicable to each type of laser is different, and values entered will be automatically coerced to the allowable range for the specified laser. A laser energy calibration is provided by APL as part of the test report shipped with each system. This calibration specifies the relationship between the flash lamp Q switch delay and the laser energy. A calibration file can be created from these calibration data and used by LIBSoft to allow an energy value to be entered directly into the software. This energy value will then be automatically converted to the corresponding value of flash lamp Q switch delay and sent to the laser. A calibration file can be created from within LIBSoft by clicking on the Create Cal File button. The energy calibration is in the form of a cubic equation. To create a calibration file, enter the calibration equation coefficients and the maximum energy used during the calibration as specified in the test report. The values for this specific laser are already entered. Once this has been done, select OK. The calibration file will be generated automatically and can be saved to a suitable location. The path to this file will be automatically entered in the laser configuration window. The use of the calibration can then be enabled by ticking this checkbox. A laser energy control will then be displayed, and the flash lamp Q switch delay control will be disabled and greyed out. Changing the laser energy directly will now automatically update the value of flash lamp Q switch delay. When a calibration is first enabled, it is worth entering a number of different energy values and noting the corresponding values of Q switch delay that are calculated from the calibration, and then checking that these match reasonably closely with the data presented in the test report. This is just to check that the coefficients have been entered correctly and that the value of Q-switch delay is being calculated correctly from the calibration. Disabling the laser energy calibration file by unchecking the enable option will cause the energy control to be hidden and the flash lamp Q-switch delay control to be re-enabled. This configuration window provides a set of buttons for manually controlling the laser, which are useful when testing and configuring it. These are start stop the flash lamp, pulse the laser, so fire a single shot, fire a burst of shots, and start stop continuous firing. To the right of these controls there is a further button to reinitialize the laser. There should be no need to use this button unless for some reason there is a communications failure between the computer and the laser. Whether controlled automatically by LIBSoft during an acquisition or manually, the status of the laser is displayed in the status bar at the bottom of the LIBSoft main screen. So down here. When the flash lamp is started, the flash lamp indicator changes colour from green to red. And a progress bar is displayed to indicate that the flash lamp is warming up to its optimum operating temperature. Once the flash lamp has been started correctly, the Q-switch buttons are enabled and the laser can be fired. During an acquisition, this is done automatically. Under manual control, the pulse, burst and continuous Q-switch controls can be used. So we can fire a pulse, single shot. If we set a burst of 10 shots, or we can set the laser firing continuously. When the laser is firing, the Q-switch indicator on the main screen changes colour from green to red. Under manual control, the laser repetition rate and energy can be adjusted as required. So if we change the repetition rate to 2 Hz, or we can change the energy to a low energy. Note that for some lasers it is not necessary to disable the Q switch before changing the repetition rate or the energy, and they can be changed while the laser is firing. The parameter values currently displayed in this configuration window will be saved to the LIBSoft configuration file when the application is shut down and automatically reloaded the next time the application is started. The parameters displayed in this window for the Lightron Bernoulli laser are slightly different to those displayed for other lasers. This is because the Lightron Bernoulli actually comprises 2 lasers, some of the parameters for which need to be configured separately. This means that the configuration parameters are essentially duplicated. There are also a number of additional controls. It should be noted that the Lightron Bernoulli laser can be configured to operate either at 266 nanometers or 1064 nanometers. The configuration required to set the operating wavelength is done in hardware and can then be optimized using Lightron's own software outside of the LIBSoft application. The only software configuration changes are made during the initialization of LIBSoft, and as long as the correct operating wavelength for the laser is selected in the LIBSoft system configuration window, no further changes are required. This laser configuration window is the same irrespective of the operating wavelength of the laser. The manual laser controls are just the same as for all other lasers and are displayed in the central region of the laser configuration window. As will be shown shortly, the Bernoulli laser can be configured to use either of the 2 lasers of which it is comprised, or both of them together. The manual controls will therefore operate whichever of the lasers is enabled, or both together if both lasers are enabled. The repetition rate and burst shock controls displayed in the upper part of the configuration window are just the same as those used for other lasers. These parameters apply to whichever of the two lasers is enabled, or both of them if both lasers are enabled. Two flash lamp Q-switch delay controls are displayed, one for each laser. This allows a different output energy to be configured for each laser. In addition, a second laser energy calibration file can be specified in the lower section of the screen. In this way, a separate energy calibration can be applied for each laser. The laser energy calibration can be enabled in the same way as for other lasers. When a calibration is enabled, an energy control is displayed for the laser to which it relates, and the flash lamp Q-switch delay control for that laser is disabled. So if we select the energy calibration file for laser 1 and then enable it, see an energy control is now displayed and the Q-switch delay control has been disabled. However, if we now enter an energy value, we can see that the Q-switch delay gets updated. And we can do the same for laser 2. An individual laser can be enabled or disabled using the corresponding button in the middle of the upper section of the configuration window. Note that if either laser is active when one of these buttons is pressed, it will be deactivated while the laser selection is reconfigured. So we've just disabled laser 1, we re-enable it, and we can disable laser 2, re-enable it. When using both lasers, it is possible to add a delay between each laser firing. This delay is configured using the interpulse delay control at the top of the configuration window. A positive value of delay will cause laser 1 to fire before laser 2. A negative value of delay will cause laser 2 to fire before laser 1. If only one of the lasers is enabled, as we've seen here, the interpulse delay is hidden, as it has no meaning. When using both lasers, the Q-switch synchronization output from either of the lasers can be used to trigger the spectrometer. This choice is a hardware configuration depending solely on which socket on the laser power supply is connected to the trigger input on the spectrometer. However, a Q-switch sync output selector is provided at the top of the configuration window to be used as an aide-mémoire. This selector does not affect the laser operation in any way, but its setting is added to the parameter configuration file saved with each acquired spectrum as a reminder of the Q-switch sync output used for the acquisition. The only other difference between the laser configuration window for the Bernoulli laser and the other lasers is the display of the crystal temperatures at the bottom of the screen. The temperature of the 266 nanometer crystal should be approximately 60 degrees, and that of the 532 nanometer crystal should be approximately 100 degrees C for stable operation. When you first start the laser, you'll see these temperatures gradually increasing till they reach their set values.